This is from the 2024 AP exam. This is the parametric question from that year. It's number 2, so it is a calculator problem. So remember how we set up our parametrics. In our calculator, under Y1, you want to put whatever the x velocity is, x prime. Under Y2, you're going to put in y prime. And then in Y3, you're going to put Y2 divided by Y1. What we're putting in there is the slope. Now you're going to put the actually call up Y2. So to get these Y1s and Y2s, hit alpha trace, and you'll see them pop up. So we want Y2 over Y1 because that'll be the slope. And the last thing you're going to do is put in Y4, and you're going to put the speed in there, which is the square root of y1 squared plus y2 squared. And that right here is your speed, the magnitude of velocity. All right, so first thing we do is set that up in our calculators. And on the calculator parts, if you are not needing to use y3 or y4, just go to the equal sign and turn that box off. Literally just go on it, click on the equal sign, it'll turn off, and that means that equation will not be calculated. So I kind of just leave y3 and y4 at the bottom for whenever I need these type of problems. Okay, a particle is moving along the curve in the xy position at t seconds, are measured in centimeters. It is known that x prime, so this is your velocity in the x direction, and then here is our velocity in the y direction. And they've also given us initial point. So we know at time equals 2, our particle is at 3,6. So part A, it says find the speed of the particle at time equals 2. Show your calculations. So A, speed is equal to the magnitude of velocity Okay, so AP is very, very picky about this. That is the actual speed formula in terms of t, but what we actually want to find is the speed at 2. So you can either say speed and say that you're evaluating at t equals 2 and then tell you exactly what it's equal to, which is 12.3048. And how we're going to do that in our calculator is you're going to go on your home screen and then you're going to get Y4 by alpha trace, and you're going to put parentheses and you're going to put 2, and that will immediately calculate that. Now what AP is really picky about, if I write the speed formula in terms of t, so like x prime squared plus y prime squared, if I say that's equal to 12.3048, they're going to take off a point because the speed is only equal to that at time equals 2. So if you want to write the speed formula with a 2 in it, then that's okay. So we could write our speed is equal to the square root of x prime at 2 squared, then y prime at 2 squared, and then immediately we can say that's equal to 12.3048. So just be really careful. They call it that it's not connecting well, so this one was in terms of t, so I have to make sure I show that I'm plugging in t, or write it that you already plugged in the 2, and then you can go straight to equals. You must show the equation. B, find the total distance traveled over the time 0 to 2. Show the setup for your calculations. Okay, so part B is distance traveled. That is the arc length, and that is the integral of speed. And they wanted us to integrate this from 0 to 2. And after we integrate that, we get the value 15.9017. And then make sure that you say the distance traveled between time equals 2 and 0 is that. Make sure you write the distance formula out, the integral of speed, and then how you're going to do this in your calculator is you're going to go on your main screen, go Math 9 to get your integral. You'll go from 0 to 2, then you go back to alpha trace and pull up y4, and then add dx. Now, yes, we're going to integrate with respect to x even though it's t because we never changed our calculator to the parametric. We just leave it straight in function notation. So we did A, we did B. C, find the y-coordinate of the position of the particle at time equals 0. Okay, so we want to know where it is at time equals 0. We know that at time equals 2, our y-coordinate was at 6. That was one of our initial conditions. We want to know y of 0. So there's two ways to think about this. The first thing we can think of is just the fundamental theorem of calculus. So the integral from 0 to 2 of y prime is y of 2 minus y of 0. So then you can solve for y of 0. Now, when we put this in our calculator, again, you're going to call the ones that you've already had. I think of it like this. So what I say is I want to find y sub 0. I know y sub 2, and I'm going backwards in time to see where I'm going. And other people like to set it up like we're starting at y equals 2, but then they're going to add the integral from 2 to 0 of y prime. And that's exactly the same thing. Pick up your calculator, and again, we know what y2 is, it's 6, and we can find this integral in our calculator, Math 8, then you're going to call up y prime, which is alpha trace y2, and when you're done, you should get negative 1.174, and then add your sentence at time equals 0. The y position is negative 1.174. Okay, now looking at part D. It says between time equals 2 and 8, the particle remains in the first quadrant. For all the times between 2 and 8, when is the particle moving towards the y-axis? Okay, so we're in the first quadrant, and we want to know when it's moving towards the x-axis. So that would be when dy dt is less than 0. So looking at our equation for y prime is equal to negative t plus the square root 1.2 plus 20, and we're going to look for when this is equal to 0. So this was already stored in y2. So basically you're just looking where y2 crossed the x-axis, and that's when the derivative would be equal to 0. That happens at time equals 5.222. So this is where y prime is equal to 0. So we're going to check to the left and to the right. So I'm going to pick something like 3 and pick something like 6 and put it into our formula. And when you put this in your calculator, you're going to get this one is positive and this side is negative. So we know we are moving towards the x-axis. Between times 5.222 and 8. So now let's talk about how this was scored. So part A was worth 2 points, 1 for the setup of speed and 1 for the answer. You will lose one of those points if you say the speed is in terms of t and then saying it's exactly equal to the speed at time 2. So be really careful with that. On part B, it is 2 points. You get 1 for the integral, 1 for the answer. C is worth 3 points, 1 for the definite integral, 1 for the initial condition, and 1 for the answer. And part D is worth 2 points, one that you're considering y prime's sign, and then one for the correct answer.